Welcome to a lesson with Dr. Powell. We're going to look at a rule called the quotient rule, but really it's just the product rule or just the boxing rule. So, for instance, what if we have function f of x is equal to x over cosine x? How do we want to take a derivative? Well, we can use the product. We can use, well, not the product rule, but we could think of it as being x times 1 over cosine x. And then we can think of boxing a product. That's what the product rule is. The product rule is just the boxing technique with a product. That's all the product rule is. So now taking a look at this, this situation, let's just go for it with the multiplication. I mean, it makes it easy enough. We take the derivative with respect to this whole thing, pretending this is the variable. So we can go 1, so 1 and 2, 2. And then we just get, so if that's a variable, that's a constant, we just end up getting 1 over cosine. And over here, if we pretend and we add to that, this over here, so thought of as a variable, and this is a constant. So this is just a constant times something. We just leave that constant there. And then we take the derivative of this. Now, this is the same thing as something raised to the negative 1 power. Now, we can take a derivative of that, negative 1 times something raised to the negative 2. But since it's a composition, then and composition turns into multiplication, we multiply by the derivative of what's put into this, which is so the derivative of cosine, which is negative sine. And then this was taken derivative at the point plugged in cosine x. Since we're plugging cosine x into here, we plug it into the derivative as well. Okay, so that right there is that bit. That's the derivative of this, but then we pretend x is a constant, so it stays right there. So we end up getting, and see this negative and that negative multiply together to cancel, so we end up just getting and rewriting this negative 2 power in the denominator. We end up getting cosine squared x with sine x up top. Okay, now we have this is the derivative. Let's add fractions to see a better form. So to do that, we could multiply this fraction, top and bottom, by cosine x. And then we end up getting cosine squared x as a common denominator. And what happens on top? We have cosine x times 1, and then we have plus x times sine x. Now, I'm going to rewrite this fraction as follows. I'm going to rewrite this as a negative sine x and put a negative here. Let's see why I did that. Notice, if I were to think of this function right here as being maybe a u and a v, like u over v or something like that, then this one right here is actually the derivative of u. This is just v. Now this right here is the derivative of v. This is just u. And this right here is v squared. In fact, we get a nice formula, v u prime minus u v prime all over v squared. This is called the quotient rule, specific for quotients. And what it does is it kind of does this, chain mechanism right here and with the boxing of the product rule. And then it adds fractions, and it does it all in one go. And oftentimes people just memorize this as a rule. So basically you just have your two things and you put them on top, the v and the u, but you take turns. The one on the top, when you take a derivative, it's positive. The one on the bottom, when you take a derivative, it's negative, which signifies from the negative 1 power type deal. That's where that comes from when we take the derivative with the bottom one. So you have subtraction there, and then that's all over the bottom squared. Now, when I write this, I actually like to use f and g usually. So when I think of another way of thinking about this, derivative of f over g can be thought of simply as I can write fg twice, put it all over g squared. And then I take turns. The f gets the first turn, the g gets the second turn. F was on the top, got the first turn. Next, because g is kind of shabby and living here in the basement with a negative attitude, its derivative will also be negative. Well, that was just a mnemonic, but no, but really that's just the formula. Okay, so you get something like that. For instance, let's just take a look at another example. What if we had something like x plus 3 over 1 minus 2x? If we want to take the derivative of this, we can think derivative of top is 1 times the bottom minus the top times the derivative of the bottom, which is negative 2, all over the bottom squared. See how quickly that went? Hence the quotient rule. Thanks for watching.